Hello, yes. Okay. So wait 5 minutes, okay? So only 5 people are joined, okay? So wait, 5 minutes. 5 minutes I will take because today I will show that interfacing, how to interface the OP server, all those things I will make it, okay? So Siemens RTU, we are we practiced with the Siemens wheels, right? Siemens 1215 RTU. So that we are going to be interfaced with our SCADA system. Okay, SCADA system. So how to interface using the OPC server? That OPC server name is called a KEP server. Like there so many OPC servers are. Then how to interface that concept we are going to be discuss. Okay, we'll discuss. So first we are writing one small program in Siemens 1215 PLC. Okay, we'll write a small PLC. So after that, so through OPC server. Okay, so KEP server OPC server interface to our SCADA system. So you can send the value or we can receive the value from RTU to SCADA, SCADA to RTU. Like that we are sending. Okay, so that we are going to do it. So what is OPC server? We will explain. Okay, so now you see before OPC server, how the data will be flow means it will be like this. You see, so direct driver they are using. Okay, audio not clear. Yes, audio okay or hello? I am audible. Our side okay. Okay. So you can check your side, G Rahul. Now we can add another presentation. So last this one. Okay. So before OPC server, okay, before OPC server, how they are connecting the SCADA and RTU, how to do it means, for example, so this one type of RTU, so the corresponding driver, okay, for example, this for Allen Bradley RTU means that Allen Bradley driver they will use and communicate to the corresponding HMI. So that means single driver we are not able to communicate to all other PCs. Okay, so for example, that RTU driver we have to buy or they will provide. Okay, they will provide the standard drivers. You can use that standard driver and send the data or receive the data from HMI. Okay, SCADA system. So for example, the driver is not properly connected, then we are not able to communicate. So that's the problem. So there is a before OPC server, I think 80s or 90s they are using for the direct driver method. Okay, so that is a big issue for communicating and configuring and no security, everything will be there. Okay, so after that, you see, for example, now number of uh, SCADA, HMI panels are there means each and every panels we need a separate driver because these also separate, this also separate means individual driver is needed, then only you are able to communicate. So that is a very huge traffic and its communication also is very difficult. Okay, so that's why the people go for the next technology they are using for OPC technology, OPC server, OLE for process control. That is called the OPC server. So this OPC server was developed. Okay, actually this OPC will be OLE for process control. That was developed by Microsoft. Okay, Microsoft. So the Microsoft OPC means what is meant by OPC? So OLE for process control. You see, OLE for process control. This OLE means is an object linking embedded concept. OLE, object linking embedded concept. That object linking embedded concept they are using for our process industry. That is called the OLE OPC server. Okay. So this OLE means object linking embedded means already I told. Okay. You see two different applications are there. Two different software is there. For example, this is the software one. This is your software two. You want to share the information between these two software. So how to do it? We need one mediator, right? So that is for the object linking embedded concept. This concept they have to develop used Windows component object model or distributed component object model or ActiveX control. These are the tools they are using Microsoft, and they developed for one software is called the OLE. So that OLE, they have to tie up with our industrial automation company. That means you go to Fishermont, industrial automation, Rockwell automation, Intuition, like that. They have to connect with Microsoft. They developed for one software that is called the OPC server. Okay. So using this OPC server, you are able to communicate between any RTU or any HMI. That is simple. So no need to individual driver or software is not needed. So we need a one common OPC software. So in that software, you can communicate any PLC or any RTU you can communicate. After collecting the information, you are able to share to any SCADA or any HMI. That also is possible. So that's why that is a very popular in nowadays. Okay, OPC server. Understood or not? Got it? This is the information. Now you see, without OPC server means here also individual network, here also individual network, then we need an option. Okay. So OPC server means these are the HMI areas. So for example, this WinCC or iFix or LabVIEW, you load one OPC server here. That OPC server easily communicate with different types of vendor, different types of RT he will be communicate and collect the information, keep it with him. Whenever that particular application is asking, he'll provide the data. So that is the advantage of this OPC server. Understood or not? This OPC server. So that's why this is very popular. So multiple device driver you can interface and multiple OPC SCADA also you have to able to interface. Okay, so that is the advantage of this OPC server concept, right? So this is the OPC and RTU how to communicate. That is the thing. Okay, you see now in our case, you see this is our RTU. This RTU we are planning to use for our Siemens PLC is one of the RTU. Then we can communicate which protocol we are using. Normally we are using for Ethernet communication. Okay, Ethernet communication with this controller. So then after that we go to the interface with our iFix SCADA. Okay, now you know how to interface, how to familiar with iFix SCADA, you know very well. So that how to interface, that is the option. You see here you can load one OPC server. That means the Siemens supported OPC server you have to install. Using this OPC server, easily you have to communicate through Ethernet protocol, and all the tags are available to here. All the tags. Now what will happen? This all the information it will be reached to this OPC server. From this OPC server, easily you have to put it to the process database, and you can connect with your SCADA picture. Right? So suppose if you want, you can send the data to Excel. That also is possible. Suppose if you want to send the data to some database, that also is possible. So that's why I told, once the data or the tag information will be collected from the RTU, some particular OPC server, that easily he will be distributed to any application or any software or any database. So even if you want, you can send the data to through cloud. Also it's possible. Okay, you can load, you supported to IoT concept and push the data to cloud. That also I will explain. Okay, so that also is a part of IoT concept. So that's why I told this is the mediator software. Okay, so earlier days they are using for the direct driver or DDE concept, dynamic data exchange server concept. Now they are using for OPC server concept. Then easily you have to implement with any communication or any driver, easily you have to configure and send the data to corresponding RTU. So that's the thing. Understood or not? Now you see, I load iFix software to here, right? This iFix software you are able to get it for 3 options. Okay, so that iFix software already you familiar. You see what other components are there? One is picture, right? This is the picture, right? This picture will be take the data from PDP, right? PDP. Now process data block, right? PDP. Now this process data block you are practicing with simulator, right? Understood or not? Simulator. Now instead of the simulator, you can take the value from this particular OPC server. Understood or not? OPC server. So you can remove the simulator driver. then you can assign the OPC client driver. You see, I fix OPC client driver. That you have to take the data through this OPC client driver. You have to take the data from this OPC server and put it to the PDP. From the PDP, it will go to the picture. That's the concept. Okay. Very careful. Once again, I will explain. Okay. You see, now this is my RTU. Just I will connect it to one pump. This is the pump. Okay. This is the pump. It's a digital output I connected, right? Digital output. Now, here one switch is there. Assume that this is the switch. Okay. This is the switch. Once if you press the switch, okay, picture, okay, from this picture, once you press the switch, the data goes to where? Tell me. The data goes to where? Once if you press the picture, switch, for example, 0 or 1, this data goes to where? Tell me. The data goes to where? What is typing? Question understood or not? If press the switch, the data goes to where? Yes, PDP, it will come to here. Okay, process data block. Okay, PDP. Then from the PDP, the data goes to where? This OPC server. Okay. Then from this PDP to OPC server, how to communicate? Using this OPC client driver. That OPC client driver they provide along with the SCADA software. So instead of this OPC server, you are practicing the simulator. Now you can remove the simulator driver. Just you can add this OPC client driver. Then directly he will be communicate to this particular OPC server. So this OPC server should be supportive for the different controllers. This will be communicate through standard protocol and reach to this controller. Then this will be activate. This motor is activate. Just you can press the switch. That data will be reached to process data block. From the process data block through OPC client driver, it reached to this OPC tag. This OPC tag will be communicate through that standard protocol and reach to this digital output. This digital output will be release the signal. This motor is running. Understood or not? So this is the path. This is the flow path from HMI to your RTU. So return path also same. You see, you can receive the value. Then you have to communicate through OPC server. The data will be take and reach to PDP. From the PDP, that will be displayed to here, the tank level. Understood or not? So this is a very, very basic concept for any SCADA interface options through OPC server. Any doubts or any doubts? Any doubt? Any doubts or any confusion you ask me, because this is very important. So that is interfacing. Now you see this is another picture. RTU standard industrial protocol, it will be communicate. Now it's OPC server. From this OPC server, you take the client server, client driver, then you can display the iFix. Suppose WinCC. WinCC means we can use the WinCC client driver and take the data. Suppose Excel, he will be send the data to Excel. That different path method. Okay, so that's why don't think that there's only one OPC server. So many different types of OPC vendors are available. You see, Kepware is the leading company. Kepware EX OPC server, Marticon is the OPC server, Top server, RS Links OPC server, NI OPC server. Like that, so many OPC servers are available in the market. So what type of RT you are using, you can check this OPC server whether these RTs are supported or not. That information they will give. Okay, so now anyway we are using for KEP server OPC. Okay, so this I installed and you can use the KEP server. You have to communicate to Siemens PLC, take the data and display to your SCADA system. That's why we are going to be doing it. Understood or not? Yes or no? Any doubt or any confusion is there? Any doubts? Any doubt? Any doubt? So today we write simple program and download and show to you how to do it. You know, this is very important. The slide already uploaded. Okay, slides are already uploaded. You go to the slide, easily understood. So OPC is free to use. That is the licensed version. You have to license. Now demo version is available. Okay, so that means this OPC server, for example, this is AB, ABB, okay, Siemens, like that means all different RTUs domain. This OP server they have to give the list. This OPC server, for example, if you go to KEP server, so what are the controllers it will be support? That list will be available. So accordingly you have to configure. Okay, so that's the thing, right? So it's a licensed version. Otherwise, 2-hour demo is there. Like for example, our iFix also is 2-hour, right? Is the server area there? Internet connectivity is required must. No. This is the communication protocol. Okay, communication protocol only is there. Not no need to internet. Okay, so for example, if you want to communicate, from this RTU, how to communicate using Ethernet protocol, right? Ethernet protocol or Modbus or Profibus, like that you have to communicate. Okay, that is a standard protocol. No need to internet. Very remote area means if you want you can connect through internet also, it's possible. So because if you go for TCP/IP protocol, you have to assign the IP address, right? IP address. After that you can communicate. So once it will be communicated, you can share the information. That's all. Okay, so that's also will be there, right? Okay. So now I will share the screen. First we can write one small program in this Siemens controller, then download and run it. Then we'll go for iFix, how to interface with OP server. I showed you, easily understood, right? Any doubt, sir? Any doubt? Yes, that you have to configure here. So that's why I told this OPC server is having the option. So whether you want send the data to iFix or you want send the data to WinCC or you want send that to Excel. So that option you are able to make a program to here through OP server is possible. So that's why that is a very popular. That's what are multi-user you can access. So because from this RTU, all the tags are received to here. Okay, every information. Then from here only you can distribute. That's all. From here itself you can distribute whatever you want. If you want, you can put a restriction only for this tags are to this particular one, and this particular tags are going for this particular PC or particular software. Like that you can make. That option also is available. Okay, password protection, everything is available. Okay, but that option is not available in the direct driver method. So that is almost outdated. Nobody is using for the direct driver method. Now the people are using for OPC server or OPC unified architecture, OPC UA. So earlier case, the OPC server only support for Windows platform. Now it will be support for all the platforms. Okay, so that is called the OPC unified architecture. It will support all the field. Okay, that's the thing. Right? Any other doubt or any other information you want? No doubt. Okay. So then first we will write a small program here. So in our case, this we are using for the Siemens. Okay. The Siemens I'll write on simple program. It's a very simple program. For example, if you close the switch, then we can switch on the lamp. Then we can add some two values, addition and so on. This is for the digital. If you this is a digital switch, this is a digital lamp. Then two inputs. So for A, B, A plus B. That means this is the analog input and this is the analog output. So both you have to control from the SCADA, iFix SCADA. iFix you are iFix little bit familiar, right? iFix you are able to understand how the process, how the software is working, you know, right? Got it or not? Any doubts? Any doubts? That's why I'm afraid, okay? Because this is the important topic for the SCADA interfacing. This concept once you understood, okay. Okay, so I'll share the screen. Minute, I will share the screen. Screen sharing is okay. You are able to see my screen. Screen sharing is okay. Screen sharing okay or not? Nobody is typing. Hello. Yes. Yes. Now minimize. So if you want, I'll switch on the camera. You see the camera. Just a minute. Hello. Start sharing. Now you see this is the PLC. Already shown to you, right? This is the PLC. You see CPU 1250. Then here we'll connect it to one lamp, right? One LED will connect. Then through SCADA, we are able to run this particular lamp and we can add, okay, this one. So this is our PC that will be connected to our network, okay. This is the area will be connected. I hope you are able to see, right? Oh, okay, sir. Now, you see here, okay, this is the program, this is the controller. This controller, how it's connected, you see. I'll show to you. This is your PLC, 1250, this is the PLC. Here we will connect it to one LED, right, LED. It will be communicated through Ethernet. That IP address we assigned, you see, this is the IP address for this particular PLC. Then it will on switch is there, okay, an Ethernet switch. From the Ethernet switch is connected to the PC, okay. This PC only it's load the software. This is the empty side. SCADA server. This is SCADA server. These were RTU. This is the communication protocol. So then already I told you this PLC address is 200.191. This PC address is 196. Okay, 196, not 193. Okay, so that how we know. We will check. Okay, I'll share the screen. Share the screen. Hello. Okay. The screen sharing is okay. Right. CMD. You see here IP config. Enter. Now you see this is the IP address of, okay, IP address of this particular PC. This is the PC IP address. Now we are make the network on Ethernet switch, right? ETH switch, that white color already shown through camera, right? Here PLC. This PLC IP address is 200.200.200.191. That is a PLC IP address. This is your PC IP address, right? PC IP address. Then we write one simple program. This is the program we are going to write. One lamp, okay. This LED, right? Okay, this LED. Then if you want, we can add some value. Here you can add this add in section addition. Okay. So this is your A, this is your B. Okay. Then output you are getting A plus B. A plus B. So for 10 and 5 minutes here automatically. So this value, okay, this value. So suppose if you go for the SCADA, okay, this is my SCADA, this SCADA, just we can give one button and one lamp indication. This button, once you press, this will be closed. Then the lamp is on. Then you can give the A value and B value. A is 10, B is 5. Then automatically it will reach to here. Then that display also. This is for your iFix SCADA. SCADA. So this how to interface. We are going to be use OPC server. That's all. I hope you understood, right? Okay. Now select premise. You go for this portal. Okay. TA portal. Just double click. TA portal. Then I'll create new project. You see, create new project. Then you can give the project name IAD 102. KD102 project number 1, right? Create. Here option is there. You see, this is the create.
No benefit, eh?
The created.
No benefit. No benefit. Don't take money. From the money. From company.
Okay, screen sharing is okay. You are able to see screen.
Don't take
Okay. So then after that, you go for here. Here also you can add the configured device. Instead of that, you go to better. Here project view is there. You see project view.
Don't take any money.
So in that project view, just click. Then next one project window will come. This is the project window. So left side, you see this is the left side. Here you see add device is there. Add device. Just add the device. Double click. Double click. Then you see controller is there. Okay. HMI panel is there. PC is there. First we can write a controller, add a controller, right? Our controller name. What is our controller number? Siemens. That is our controller number. Siemens 1200 series. Okay. 1200. Exactly Siemens 1250. Okay. 1215. Okay. The thing. Now you see expand this one. Okay. Expand 1200 series. Then CPU. Then you select this is our controller. So this number, okay, this number should be available the corresponding CPU. Okay. So if you want, you can see the camera through camera already shown. So this is the part number. You see 6ES7215-1AF. This is the number. Then this information, full information is available. So the scan speed. The scan speed is 0.08 millisecond. That much speed, execution speed is there, that information. Otherwise better you can download, okay, you can download this manual. It's available in the Siemens library. Full informations are available. Okay, this one. This version 4.2 is a operating system. Okay, then press OK. That's all. This is our first step. Our first step. Then, okay, then you see after that, rotating. Okay, so after that you go for this IP address we can assign. What is IP address? What is IP address of this? What is IP address of this PLC? What we decide? What is IP address? Typing 191 G 191. So because you see CMD should be same network, otherwise gateway is needed. You see this is the network. You see IP config, that is a command. IP config. That IP address is, you see, 196 for the PC. Then that should be the same address. Here. Okay, actually 191 already assigned. Okay, so how to assign the IP address? Just we know. Select. Here you go to the right click, this area. Select the controller. Just to select the controller, right click. Then properties. This window will come. Okay, this is the window. In that properties, you see properties. You select Ethernet address. Here, Ethernet address. This Ethernet address, this is the default address. Default address is 192.168.0.1. Now this we change it to 200. Okay, 200.200.191. That I am going to be changed. Just you select 200.200.200.191. Then that should be make your network. That you see, that is add network. Add network. That network name is PN_E. That is a default name. Okay, it will come. That IP address is assigned, and you can press OK. Right? How to do it? Just right click, properties. Then you go to the this area, Profinet and Ethernet address. Right? Here you make one network. Then you can assign the IP address of this one. This is the first step. Then another one important information is that if you want, you can communicate, share the information. Then you go to this protection, security, and connection mechanism is there. This is the very important thing. Connection mechanism. This connection mechanism, you can share the permit to access the memory. You can transmit through network. That you have to make a put get communication. That means you are allowed to communicate through network. That you make a tick mark. That's all, sir. Same. That is your first step. Save this one. Then after configuring this one, just right click. You see compile option is there. Compile hardware. This is the hardware configuration. Rebuild all. Hardware configuration. That's all. Now you configure IP address. You assign the IP address and you have to enable the memory sharing between this controller to any application. That is also enabled. Next we are going to write a program. So that program means you see left side the program block is there. This is the program block. Okay. This is the program block. Just to expand the program block. OB1 organization block 1. That is the main program. Just to double click. This window will come. Okay. Here you see right side all the project sections are available. Just you select bit section. See bit section and coil section. Okay. Then if you want you can add see mathematics section. Math addition like that we have to do it. Now only simple 2 operation we are doing. Now you see this is a switch address you can give. Okay. So for example boolean tag. This is the boolean B switch B underscore switch 1 enter. Now just right click define tag. That address is a M memory percentage M. Okay, percentage M 0.0 define like this. Should or not? This address, this is switch. Now this lamp address, already the hardware one LED is connected. Okay, that LED address. Okay, this LED address, LED 1. That address just right click, define tag. That address would be given to output address Q. Okay, Q 0.3. That is address. Q 0.3. Q means its output. 0th byte, 3rd bit, the LED is connected. Okay, that LED is connected. Right. That is another person. Next, we are writing another program. It's input, just addition. Okay. Just you go for the integer addition. I am doing. Then here input A. In underscore A. Right. Just right click. Then define tag. You can give one memory. Okay. This is the memory. That memory also it's a global memory. It's a MW2. So automatically that address will be coming. You see here. MW2 address. Then you go for the input B. IN underscore B. Enter. Right. Right click. Define tag. Then select global memory. Integer. Define OK. MW4. Next address you see A plus B. Okay, A plus B is output, right? You can give any name. Out underscore A plus B if you want. Out underscore A plus B. Enter. Just right click, define tag. That also is a global memory and integer define. That's all. This is my simple program. You see what we are going to be do, just you can assign one switch from iFix, you can close the switch, then this is on. Then if you want send the value from A and B from the SCADA and this will be summing and that also is displayed to the SCADA. Any doubt for this simple project? Any doubt? Any doubt? Just right click and compile. You see compile all software rebuilding. Okay. So then the program is ready. I am going to be download. Compile. First hardware configuration, compile, already compile, rebuild. Then after that you can right click, compile, software rebuild all. Now you have to download. Just right click. You see download to the device. First hardware configuration. Download. Then you see this is the IP address. Then network address, select the PC network card, then the network address, already we created address. Then you have to search button, automatically this PLC will be displayed to here. You see, searching. Yes, you see, this is the thing. Now, this is the IP address we assigned. Already this IP address is available to this particular network. Then you can load the information, select and load. Loading. So while loading, he is asking, you want stop all? Yes. Stop all and load the new program. That's all. Then you can start the module. Now you can monitor, go online. Go online. The option is there. Go online. Then monitor option is there. Just to monitor. Download once again. Stop all and load once again. Then start the module. That's all. You see, monitor. Now the program is ready, right? Program is ready. Now just right click, you see, right click, modify to 1, that output is on. Modify to 0, output is off. If you want, I will share the screen. Now you see, percentage is a syntax. Now you share the screen. Start. Now you see that is off. Okay, LED is off. I will open the program and right click, modify to 1. Now you see it's on. Right? This is the thing. LED is on. You see, LED. This is a digital output. Digital output, the LED is on. Suppose if you want, you can off. Just I will select. Now the LED is off. R2 side program is clear. R2 side, no doubt, right? I hope you understood. Simple program. You see the program. Any doubt? Any doubt for up to here this level? This already I explained once. Okay, 2 or 3 day, 5 day class before. Okay, explained. You remember or not? Simple. That means I write a program and download. That's all. Okay. Next we'll go for the OPC configuration. I will this one. You see, sir, this one here. Oh, this one here. This program ready. Now we'll go for this area. Here, how many tags are there? You see, as per the program, how many tags you see? Here, how many tags? Switch one tag, lamp another tag, right? Then one addition instruction, right? Addition instruction, A, B and A plus B. Total 5 tags. This all 5 tags you have to configure to the corresponding OPC server. Okay, OPC server. So which server we are going to be used is a CUP server. It's a downloadable. Okay, if you want, you can download and configure it. Then that I will share once again. The screen I will share it. Okay, sharing. Screen sharing. Okay, screen sharing is ready. Screen sharing okay. Yes. Now minimize. You go for software side. You see, this already installed. Okay, you see, So today I install this the software. Web server. Okay, just to double click this web server. This window will come. This window will come. You create a new project. Okay, new project. Just click the new project. Okay, this one. Then connectivity. You go for the connectivity here. Okay, web server. This is a demo version. Web server. Connectivity. First, you can add the channel. Okay, channel. And just double click. This window will come. Here you can select this OPC server. It will be support these many type of controller. It will support. You see, Alan Brawley also is supporting. He is supporting for some other automation. You see, CodeSys also is supporting. He is supporting for Honeywell PLC. He is supporting for all this. What is our PLC? What is our PLC? It's a Siemens. You see, Siemens. These many controllers are there. You see, S7 is there, S5 is there, S7 200 is there. Which protocol I have to select? Tell me, sir. Which protocol I have to select from the list? Tell me. You see, Siemens S5, S7 plus Ethernet, S7 200, TCP/IP Ethernet, TCP/IP server Ethernet. Which one I have to select? Simulator. Which one I have to select? Anybody is typing? Anybody is typing? One? Siemens TCP/IP. Very good. Siemens TCP/IP you have to select, right? Then you select for Siemens TCP/IP Ethernet. That's selected. Okay. Ethernet. Then next one. Channel name. If you want, you can give the channel name. Any name, otherwise channel one. Leave it. Okay. Other channel, IAD channel. IAD channel CH. IAD channel 1. Then next. Adapter. So adapter means that PC. This PC address. Okay. You see 196. 196 the PC adapter. Okay. Is PC adapter. PC network card. Then next. Then these are all latest value. All the tags you can go for the default values. Next. That's all. The channel is ready. After channel configuration. Okay. Channel configuration. You go to add the device. This is the device. The device you see question mark is there. That means that address whether Siemens controller. That is the thing. Okay. Just you select device PLC. Okay. Siemens SIEM. Siemens PLC 1. Okay. Siemens 1. Next the type of model. You see which one you have to select. You have to select for the S7 1200 series. Okay. 1200 series. Then next. Here you have to assign the PLC IP address. What is the PLC IP address? Tell me. What is the PLC IP address? What is the PLC IP address, sir? Tell me. What is the PLC IP address? As per our case. 191. Right? 191 you have to assign here. 200 dot, 200 dot, 200 dot, 200 dot. Okay. Dot 191. Then next. You have to assign. Then next all are default option. It's allowed to all the tags and port numbers. Default only. Nothing is there. Finish it. Now this is over. Okay. You are configure the channel as well as channel configuration is ready. Then the PLC is ready. Then here we can add the tag. How many tags are there? We are having the 5 tags. Okay, 5 tags. So all 5 tags we can add. That how to add it? You see, just to select. You can give the name. So there we can give for some other name. Okay, switch and all those things. Here if you want, you can give for iFixed any name. Any name you will give. Switch 1, SS1. Okay, we'll go for switch 1, right? It's a boolean B. Switch 1 is a boolean. That address, what is the address? M0.0. That means memory 0th bit and all those things. The data type is default. If you want, you can change to boolean also, no problem. Nothing will happen. But the correct address should be assigned. Otherwise default. Then okay. Now it's a Boolean data type. Now next, create new one. Okay, another one that is called the lamb1. Lamb1 underscore is a Boolean. That is also the Boolean data type. That address Q, okay, Q 0.3. That's all. Q 0.3 plus okay. That's all. Then next, you see A. Okay, tag A. Tag underscore A. Right? That address MW2. Then that is the integer data type, right? If you go for, so you can select the integer data type. Integer, integer, int should be there, or word, floating point, here, upstairs is will be there. Or double, you go for character, byte, short, word, long. Okay, we'll go for default, then what, double, so you go for the default things. Okay. You see word, default it will take as a word. Then right click MW is he answered as a word. Integer also one data type is there, but it will not display, right? Then next address tag 3, tag B. Okay, tag B. That address MW4. MW4. That also you can assign as a default. Then it will be converted automatically as a word. Then tag A plus B, right? Tag A plus B, then that address MW6. That's all, sir. Now all three tags are created. Right? All three tags. This address, then that corresponding data type and update time, everything will be displayed. Understood or not? This is the thing, just to save this one. Save. So we'll say you want to ask a password. So now I don't want to give any password, just to save it. That's all. You can give the name. Just one. Any name. Okay. Save it. That's all. So I go to the CUP server software, then channel configuration, then the PLC configuration. In that PLC, I am using for all 5 tags I configure. That is your first step. Save it. That's all. Okay, save. Right. The same. Okay. Right. Now it's ready. Now you see whether the data will be properly working or not. We have to check it. That how to check it. Here one small option is there. You see this is the OPC server running, client running. You see. The thing, you see this one here. OPC server quick client running. Just click this window. The next window will come. It will be shown to like this. Like this. Now, this is the thing we configure. You see, this is the thing. Siemens, IAD channel, Siemens. That you have to expand. You see, here expand. Click this one. Now, automatically, all the tags are coming. You see, these are all tags. Okay, lamb, switch, A plus B and B. Now, we will go and activate this particular this condition. This is very important. The quality should be good. Suppose here you are getting for bad means that signal is not properly connected. That channel is not properly configured. That is a big error. Once again, you can do all the steps. Then you can make everything as a good. Good means okay. Now, from here also, if you want, you can activate. That how to do it, you see. This switch is, for example, now I select this switch, right click, you see, write, okay, write the value. Here you see, just you can put, this switch I put it for right value is 1, apply, it's working. If you want, you can see the programming side, it will be working. Now you see, this is the okay, this is working. Now, once again, I will close this one. You see, select here, this value, I put it for 0, then apply. Okay. Now you see, this is off. You see how to do it? Just right click, write the value. You see, write the value from this OPC server. Okay. From 1, I put it to here. You see, apply, it will be on. Then here 0 will be off. Now up to OPC server is clear. No doubt. Okay, OPC server is clear. Now up to OPC server is ready. Okay. Now this is the over. PLC side is over. Then it will communicate. Then OPC server, kept OPC server. Here tag, everything is okay. Next we'll go for the iFix. This is your iFix. This iFix, how he will be take the data from here? Then you can use for the iFix client driver. This is for iFix OPC client driver. So then he will be take the data and put it to this PDP. From the PDP, it goes to the picture. That's all. Now this is okay. This is ready. This part we are going to be do. Okay. Now earlier case you are practicing with, instead of OPC client driver, you are practicing with simulator, right? We can remove the simulator and you can add the OPC client driver. That's all, sir. That's the thing we are going to be doing. Minimize. Understood or not? Minimize. You go for this corresponding software, iFix software. Just to select iFix. System configuration utility. Just click. Here configure SCADA. This here you see simulator. Earlier it was in the simulator, right? Simulator. Now I will go for OPC client driver. OPC client driver, press OK and add this one. OPC client driver, OK. Then this SIM should be changed. Initially it was in SIM, okay? SIM. Now if you remove to OPC client driver, after that save this one. File, save and file exit. That is a step. Next we can start the iFix. Double click, start iFix. Continue. Then you go for the PDP, process data block. Just open the PDP. Then create a new PDP. Okay, select create new PDP. It's a hardware. If you want, you can give the here I put it. You see, hardware experiment, hardware OPC. Then it save us. Created. Then you see here the driver is the driver. Then click this driver. OPC configurator. OPC local client driver. Connect. Connection established. This will come. Here it will come. Then first you can add the OPC server. How to add? Just right click. Okay. Or here you see that option is there. Select this OPC. Then come back to add the OPC server. Click here. Then he will be search the OPC servers. These are the OPC servers. In this system, this many OPC servers are there. What is our OPC server? Our OPC server is this one, Kepware exe. This is the OPC server. Just to select the Kepware OPC server, finish it. Then if you want, we can give the name. Here you can give the name. Otherwise, you can use the default name. Suppose OPC1. Don't forget to enable. This is very important. Enable this one. Enable. Then next you can add the group. Group means, for example, if you go to the plant, 1000 tags are there, means first 200 is one group. Next 200 is another group. Next 100 is another group, like that. Now anyway we are having only 5 tags. That will be make a single group. Okay, single group. Then in that group we are going to be add the item. So item number 1. Okay, item 1 is a switch. Okay, iFix switch. iSwitch 1. Then you have to browse that option. You see, browse option. Just click this browse option. You go to the Kepware. the configuration channel will come. You see Siemens, the cam is there. So now you see switch. It's a Boolean. Okay. This is a switch is a Boolean. That PDP, this PDP, whether analog or Boolean, that is a Boolean. Okay. Boolean digital input or digital output. So then here you have to select the better digital output, because digital input means read and write, digital output means only write. Now we are planning to write the value from SCADA to our RTU. So that means it's a writing means you go for output. Okay, output. This is the digital signal. That's why I selected digital output. Okay. Then save the project. Okay, save this project and stop and run this one. Here also that monitor option is there. You see monitor. This monitor option is once click. There that signal should be good. If there is not good means here if you bad means that is not properly connected. Now it's okay. Now if you configure once again, you go to the configuration mode, next tag, okay, add another tag, then enable these for the iFix lamp, iLamp 1, then browse same method. Kept server, channel, the Siemens, you have to status of lamp. That means it's a digital, that should be input, because you can read the lamp status, that is the input. Okay, then save this one, stop, run and monitor. That also is good. Like that we go for some analog also, configuration, then analog, input A. Okay, iFix in A, browse, you see, browse this one, then enable, select IA Siemens, input A tag, it's analog output. Okay, so from SCADA you are writing analog output, that's why I put it to here. Then save this one, save, stop, run and monitor. Now you minimize this one, automatically it will be refresh and the tag will be coming. Reshort, you see. Here, this is the tag path. You see, this is the tag path. The current value will be question mark. Now, once you run, you see, digital input, the scan time I am changing. Scan time I am changing to 0.1. Then save it. So, this DI block, okay, DI block, you should be given the writing permission, right? DI block, then advanced, that is the writing permission. Enable write, then save it. That's all. Save this one. Okay, save this one, then refresh it. Now all the channels are ready. Save it. Same thing. Okay, refresh it. Then we'll go for as per your project. You see here this project. Then switch. Just you select the switch. Switch. SW switch. Select data entry expert. Okay, data entry expert. It's a push button entry. Data entry expert, push button entry. Then we'll select data source. Browse. iFix. You see switch 1. F underscore CV, the current value. F underscore CV assigned. That's all. Okay, that's all. Now you see. Then like that, if you want, you can go for the lamp. Just select foreground animation, foreground. Okay, foreground color. We have to assign the lamp indicator. Select lamp F underscore CV. Just we can assign. That's all, sir. Okay, the color, if you want red color and green color, we have to make it. Red color for this one, green color for your on condition. That's all. Okay. This is the thing. Then if you want, we can send the value. Okay, send the value. That again you can go for the data link stamper, browse, iFix, input A, F underscore CV. These all the things are remaining same. Whatever we are doing the simulator, same way we are doing. Then data entry expert, glider, write continuously. That's all. Save this one. Save. Now we have to run the picture. It will be running here. Here it is running. Okay. Running. Okay, now minimize. You see, I will go for the program here. This is my program. That you know very well. This is my SCADA. This is SCADA screen. Now I press the button. You see, open, open, close, open, close. See the status. This is assigned to this particular tag, right? This is assigned to this switch. This is your iFix, right? iFix. iFix. From iFix, I am pressing the button. You see, press the button. Open, that is stop. Close, on. Right? Open, it will be off. Understood? Now, if you want, you can send the value. Now, here you see 0, 0. I will pass the value from SCADA. Just to select, click here. Click this window. I will be enter the value. You see 50. 50, you see automatically the 50 will be reaches to here. Now if you enter to 17, it will be coming. Understood or not? This is the way. So now through SCADA, okay, through SCADA, for example, if you want, I will share the lamp. Here you go for this one here. Share that camera. You see. Here I'll take the screen. This one you see. Here you see. Open. Close. You see. So this delay, some delay is there. That also you see able to, some configuration settings maybe is there. That we have to change. You see, on. Open. Open. Close. Understood or not? This is SCADA interface. So like that, now I show one analog channel, one digital channel also I will explain, right? Then remaining thing, we have to do all those options step by step. True or not? Yes or no? Because once again you can watch the simple video, you get good idea. Because without hardware we cannot do anything. Okay? Without hardware we are not able to do anything. So now I write a program how to configure this iFix and how to interface with the SCADA. This all the steps are clear. Next tomorrow, how we can send the same data to your Excel sheet. Excel also we are able to send. Okay, tomorrow I'll show to you how to send the Excel sheet. Understood or not? SR, IP, specific IP, anyone after config we can put. Yes, no problem. Default IP address is 192.168.0.1. That is a PLC default IP address. If you want, you can change it. No issue. That hardware configuration, right click, hardware configuration and compile, download it. So that should be in the same network. That's all. Delay, that SCADA settings will be there. That default maybe 1 second or 2 second update will be there. That SCADA system configurability, that update time default maybe 1 second or 2 seconds is there. That's why that delay will be there. Some settings were there. I will check it. Okay, tomorrow I will show to you where it is there. Then automatically it will upload. Because so that's why I told, if the SCADA update time maybe the delay will be there. That delay we have to study. Maximum is a millisecond. Put it or not? Yes. Okay, today a little bit lengthy class. I think technically also a little bit strong. So that you can watch once again. Any doubt tomorrow also you can discuss, no problem. Yes, same method only there is, but that it's not a EX file. They will configure the entire path. They will make a final project they configure entire path and it will be run properly. SCADA, they are not making any AX file. It will be configure and path settings only. So that's why MTU, that my SCADA server is very important to setting all this path. So WinCC, maybe they are using for a different method. So if you want, we can connect on WinCC. Profinet will connect and show to you. Now this SCADA, so you see here, you see what to do. This case, this data, this here analog is there. For example, this is your analog value. This analog value, if you want, you can send to the ODPC. How to send? You can send to alarm concept. This enable, this service enable, the data. This real data will be stored. Whenever alarm will be generated, automatically it goes to the ODPC. That's all. You can send from here, or you can send the value from here also. From here also, you can send the data to the database. That also is possible. So because from RTU, okay, from RTU, you can receive the data to OPC server, right? OPC server. Then you can go for iFix, right? iFix. From iFix SCADA, you are sending the alarm to the particular one, right? Otherwise, from here itself, alarm is a part of iFix software, right? Here itself, because AA block only, you are assigning the alarms, right? This alarm it will go. But from here, if you want, you can store the database. That also is possible. Through iFix, you go to the iFix and send the data to database, or from OP server also, you can send the data to database. Two method is there. This is the through iFix. This is a direct. That's all. Understood or not? So if you go for database concept through ODBC only, you can connect in the case of iFix side. But if you OPC server, you can directly push the data. So through Node-RED, I'll show to you. Okay, how to send the data through Node-RED. iFix, I'll show to you. Okay, sir. Today, I think some people are left. Just little bit strong topic. This is the main topic actually, SCADA interfacing. So why this window will frequently come means is the demo version. That's why he is coming frequently. One window will come right here. So that is the frequently coming because of demo version. Okay, sir. Tomorrow I'll show to you with the Excel sheet. Any doubt? Thank you so much. Okay. Once again, you can watch the video and easily you can try to understand. Okay, sir. WinCC also I'll take on class on this. Okay.
You are currently the only person in this conference.
Number of places, this is 11.